In this video, we introduce a novel gravity compensation mechanism using torsion bar, which called torsion bar variable gravity compensator, TVGC, with high torque compensation and expanded workspace. Robots like manipulators that handle large payloads, as in industrial applications, use gravity compensation mechanisms to counteract gravitational torque. In industry, also academia, gravity compensation mechanisms are commonly implemented using coil or gas springs, or counterweights. These mechanisms have the advantage that simply scaling up their size allows them to generate large compensation torque, enabling effective gravity compensation with a relatively simple structure. But, in contrast, as the compensator is scaled up to generate higher torque, the dead space volume and weight increase accordingly, reducing efficiency. Moreover, due to its weight and externally mounted configuration, it is applicable to only a single joint axis. TVGC addresses these issues by using a torsion bar as the elastic element and adopting an embedded design integrated within the robot link. By leveraging the torsion bar's low weight and small volume, we realized an embedded design, and its high stiffness enabled high torque compensation. In addition, a reducer was used to control the torsion bar's small displacement. In addition, due to its embedded design, the TVGC has the potential to be applied to other axes of a manipulator, unlike conventional mechanisms that typically compensate only a single axis. The baseline compensation principle of the TVGC mechanism is as follows. Although the components operate simultaneously, for clarity, the mechanism is described sequentially along the power transmission path. The joint driving motor rotates the link by theta manipulator, and the reducer housing rigidly attached to the link follows the same rotation. Because the reducer input shaft is fixed to the base, the joint rotation results in a relative counter rotation of minus theta manipulator at the reducer input. This relative motion is reduced by the gear ratio N, and transmitted to the torsion bar via the gear train, where it twists within the elastic range to generate a restoring torque that acts as the gravity compensation torque at the joint. The optimal compensation principle of the TVGC mechanism is also described in the same manner as the baseline compensation principle. The required gravitational torque varies with payload and configuration, i.e., equivalent mass and center of mass location. A torque limiter regulates the transmitted input torque by allowing relative motion only, when the applied torque exceeds a preset threshold. The regulated torque is amplified through the reducer, and delivered to the torsion bar, inducing the desired torsional deformation. By controlling the torsion bar twist level in this manner, the TVGC provides variable, load-adaptive, optimal, gravity compensation. Through an embedded design, we completely eliminated external structures that create dead space and reduce the workspace, thereby expanding the range of motion. The compensation level can be adjusted by tuning the torque limiter, 0 Nm compensation. 21 Nm, link weight 5 kg, compensation. $90 Nm, 10 kg payload added, compensation.